So during this, if you have a question, you could type it into the chat, or you can just unmute and ask. If I'm obviously in the middle of another question, just type it into the chat. Don't, unless you're asking a question about the question I'm working on. All right. So for both for all campuses, your 130 test, 120, 130 test is going to be very, very similar to the 110 test, with the exception of adding in now more like some flow rate questions. So you probably haven't seen flow rate questions, and which is basically calculating milliliters per hour or drops per minute, and then revisiting some of the things that you have seen. So your metric to metric conversions, your household to metric conversions, doing the, your oral medications, your suspensions, and then your reconstitution type questions. So as always, remember to know your conversions. If you are at Allegheny campus, you usually don't need to worry about the cup, pint, quart, but it's good to know because you might see it on the NCLEX at some point. So it's good to know what these are. And then for your basic metric conversions, that's for everybody. I don't think you really need to worry about kilograms to grams, pounds to ounces, pounds to, weight-based ounces, and the meters, centimeters, millimeters. I don't think you need to worry about those, but if you do additional practice, like if you find some handouts or things like that, or worksheets online, they might give you those. They're good practice because you're still doing conversions within the metric system, and doing some more household type conversions, household to metric conversions. But I don't think they're going to ask you to convert, pounds to ounces. With your intake for North, Boyce, and South, it's just calculating your, they're going to give you a quantity in ounces of a particular substance, liquid substance, and you're just going to convert it to milliliters, add those up. You did that in 110. For Allegheny campus, it's the fluid replacement type questions where the patient will void, and then for every amount voided, you're going to replace with another volume. And that's what your intake output calculation looks like. So let me get to the things that are a little bit new. And that's going to be these flow and drop rate calculations. So let me pull up one that we can see. Okay, so let me start with these here. So something you need to know about flow rate, there's two types. I'm actually going to start with number 10 and I'll come back to 9. There's two types of flow rates. You have flow rates that are in milliliters per hour, or you have flow rates that are in drops per minute. Okay. So if you ever come up on a question and it doesn't tell you, here it tells you to look to what you would put in the pump milliliters per hour. You want to use the questions to look for clues for what they're looking for. If they want to know drops, drop rate, drop factor, anything drop related, they're going to say things like your drop factor is your tubing, you have a micro tubing. They're going to give you information that should tell you what type of flow rate they're looking for. Okay. But for the most part, if they just say flow rate, or sometimes it'll say drip rate, they're talking about milliliters per hour. And if they want to know drops per minute, they'll have to give you the drop factor. And so I'll show you examples of that here as we move through this. So this question, a variation of this question, is also on the Allegheny 130 practice. But basically, flow rate with this, you're just going to take the volume over the time, and that's going to give you, and you're just going to reduce that. So your answer for this question would just be 125 milliliters per hour. So nothing more. Believe it or not, this is a commonly missed question. And the reason being is because you know, a lot of times you're looking for more math to do than you need to. All this is a reducing question. So let's go up to number 9 and look at the other variation. This is a drop rate question. How do I know that I'm going to be calculating drop rate? Because all it says is, what is the flow rate? I know because it tells me the drop factor. Now, in this particular question, it doesn't tell you what the drop factor is, meaning like what its units are. You need to know, just in case you get a question like this, that means 20 drops per milliliter. Okay, so the drop factor is basically what is the diameter of the tubing and how many drops does it take to get to a milliliter. The smaller the tubing, the more drops it takes to get to a milliliter. The more, or the larger the diameter of the tubing, the less drops per milliliter. Okay, and if they say microtubing means it has a drop factor of 60 drops per milliliter. So it may not give you that number. You're supposed to know what that is. And that, again, that's more so for North Boys South. But you might see it on the NCLEX. And then now, hopefully, you will remember that if it asks. All right. So this says to administer gentamicin 60 milligrams in 50 ml dextrose 5% water over 15 minutes every 6 hours. With a drop factor of 20, what is the flow rate? So there's a lot of information here, right? I'm looking at this and I just got a little bit overwhelmed. So it tells me 60 milligrams in 50 milliliters dextrose 5% water over 15 minutes every 6 hours. So what do we need to do? We need to figure out what we're looking for flow rate wise. There's actually a lot of extra information in this that we don't need to know. The first thing that we don't need to know is we don't need to worry about the 60 milligrams. And the reason we don't need to worry about the 60 milligrams is because when we're talking about flow rates, we don't really care about the strength. We just care about the rate in which it's flowing, okay? Thus the name flow rate, right? So I do care about my volume and I do care about my time. Now there's 2 times here, right? So over 15 minutes every 6 hours. So when I'm reading this, to me, it sounds like you run this for 15 minutes, then repeat it every 6 hours is how I'm reading this. So the time that's important is the 15 minutes, okay? So what I'm going to do is I'm going to solve for drops per minute. Ideally, if I'm using dimensional analysis, I can just set this up using the information that I know. I know I have a volume of 50 milliliters that's infusing over 15 minutes. I have a drop factor of 20. And when I set this up, I'm going to get exactly what I'm looking for. 20 or drops per minute. Now, the reason I'm showing you this too is because a lot of times, especially if you've been stuck on in the 110, ordered over half, like kind of structure, when you do flow rates, order over half doesn't work the same way. It can work, but it can be frustrating. And so sometimes it's better just to kind of go back to your roots if you haven't already, and kind of dive into dimensional analysis just to kind of get a good foundation. But 50 times 20 divided by 15 will actually give me 66.6 repeating. Okay, so I can't have a decimal drop. So this, I'm actually just going to round it to 67 drops per minute. Now there's a key to this. So let me just see what number is that? That is number 9. I just want to see if I'm getting the same thing. So, okay, yeah. So they actually wrote out both answers, 67 drops per minute. They also wrote just the regular flow rate, 200 milliliters per hour. My recommendation is that if they give you a drop rate, they probably, or drop factor, they probably want to know the drop rate. If they don't, then they probably, don't want to, they would just want to know milliliters per hour. Since both answers are there, it might be a good idea just to show you how, if you are ever wondering, how do you go from milliliters per minute to milliliters per hour? First of all, no, you should label the answer drops per minute. The drop factor is drops per milliliter. Good question. So there's two ways to do this. I sit there and I put this in my head and I said, okay, in 15 minutes, 50 milliliters will have infused. In 30 minutes, that's 100 milliliters. 150 in 45 minutes, 200 milliliters in an hour. But the alternative way is, again, just converting minutes to hours. 60 times 50 divided by 15, and you'll get 200 milliliters per hour. Yeah, did she put, maybe you're trying to tell me the key said nope, drops per minute is correct. Okay. Or was what Maddie had also put. Sorry. All right. So those are examples of flow rate questions that you might see. Again, if they give you a drop factor, if they mention microtubing, that's usually your clue that they're looking for drop rate. If they don't give you that and they just ask for the flow rate and there's nothing indicating anything with drop factor or microtubing, then you can assume safely that it's milliliters per hour is what they're looking for. All right. So this is a little bit of a confusing question because it says you have 250 milliliters, dextrose 5%, water, IV running at 100 milliliters per hour. What is the flow rate? Well, the flow rate is 100 milliliters per hour, right? So I don't know if there was, let me just double look at this. Yeah. So I think that was maybe just a poorly worded question. Because if they're just asking what the flow rate is, it would just be 100 milliliters per hour. Now, the way that I think this question should be asked is how long before this infusion, like we need to change it. So maybe that's what they're trying to get at, is how long before we need to change the IV. So in order to do that, and you may already know how to do this, but I'm going to take my total, the 200, get rid of milliliters and calculate for hours. So just put that 250 divided by 100. And I can say that this will run for 2.5 hours. So you can write that as 2.5. Excuse me. 2.5, 2.5, 2 hours, 30 minutes. You can write that a variety of ways. All right, another flow rate question. This says a patient is getting a tube feeding of Ensure. It's running at 120 milliliters in 90 minutes. Calculate the flow rate. Now, here it tells you milliliters per hour. If it didn't, because there's no other things indicating tubing other than tube feeding, it doesn't say microtubing, it doesn't say drop factor. So we're going to assume milliliters per hour. And again, the question tells you milliliters per hour, but I'm just telling you in case you run into a problem and it's not there. Now you know. All right. So I'm going to take my 120 milliliters over 90 minutes. I'm going to multiply by or convert to hours. 120 times 60 divided by 90 gives me 80 milliliters per hour. And again, this particular problem is also on the Allegheny practice test. I just wanted to show you a different version or variation for additional practice. And then also so you can kind of see how these can be alternatively written, particularly for like NCLEX, ATI, and then more importantly for you guys at North-South Boyce, because this is a little bit more in line with how your questions would probably be asked. All right, so 800 milliliters, 8 hours. What do you think the, you can just type it into the chat. What do you think that infusion rate would be? Or what do you know the infusion rate to be? Good job. Got it. Yep, I'm assuming that means what they said. Yeah, so this is just a matter of taking your 800 milliliters, 8 hours. You hope for a question like this, right? So 100 milliliters per hour. All right, go ahead, Mandy.
Can you convert the 90 minutes before? Like, can you just, into like a decimal?
Sure, like 1.5.
Yeah. And then just divide. Okay.
Yeah, so alternatively, and I apologize, I usually show that. So you could write it like this, and then you're going to get the same answer. So yes, you can do that. Absolutely. You don't need to worry about heparin. That will be third semester. So I don't think there's anything more on here to worry about. And my hope is that you are still pretty good about like suspensions and the reconstitutions and things like that. But if there is a question, just stop me, let me know. I can also pull up the other review packet for Allegheny campus, and then you can kind of see some of these things. If there's something, I imagine most, if not all of you, are fine with the sliding scale. That's just reading it and given the units. This you won't see at Allegheny campus, but this you've already seen in 110. At the other campuses, this is just your reconstitution example. Just remember to look in the label for your concentration, and you should be okay. All right, let me pull up the other thing here. And if you came in after I said this, please put your name and the campus that you are at into the chat. That way I can keep track of attendance, please.
Dr. Rad.
Yes.
Would you be able to go over like one or two problems of the fluid replacement for the intake? Thank you.
Yeah. Are you talking about like the urine output ones?
Like with the peg tube?
Oh, yes. Oh, wait. Peg tube?
Like you put 40 ml in the
Oh, yeah. Yes. I'm going to pull that up right now. Thank you for
okay.
Yes, absolutely.
Thank you.
You're welcome. Yeah, good question. I just want to make sure we were talking about the same thing. So, and we are. All right. There we go. Give me one moment because I'm trying to share what I just opened so we can all look at it together. So again, these are all like, even with my writing and everything like that, if you open up the 23 spring versions of the practice sets that are in the folders, and you might need to look around a little bit. So what I was just showing all of you was the 220, 230 review for Boyce campus. Again, there's like more than like the last few questions on there don't apply to you, but I wanted to at least show you like that there are some practice questions similar to what you're going to see that I maybe didn't add on here. So this is like this question here that says question 1, the fluid intake. This is what you'll likely see at North South Boyce. And then what you're going to likely see at Allegheny campus is right here. So I even wrote that. I didn't write Boyce there, but I wrote Allegheny. So let me do this one. This is good to know as well for the other campuses, because you might see something like this later on down the road. I did pull this question from a book. So, all right. Okay. So I'm actually going to go ahead and I'm just going to change some of the variables here, just because that's what they're going to do to you on the actual test. Okay. Let's just say. Okay. So all 3 of those variables can be changed in this particular question. You can do dimensional analysis with this. It is a little bit challenging. What I recommend doing is just, it's actually ratio proportion that I end up doing. That is, I think, a little bit more straightforward for answering this question. And then I'm going to give you kind of like a formula to follow that should help you out. So first of all, what we need to do is, before I give you any kind of like equation to utilize, we need to know what the variables are. So this number here, if the urine output for the last 4 hours is 800 milliliters, this is considered the actual output. Sorry. Trying to keep my pen color consistent. All right. So the 800 milliliters is the actual output. Okay. That's what the patient actually voided, was 800 milliliters. This right here is obviously the replacement volume, because it says to replace with 75 milliliters. And then what I've dubbed like the theoretical or the expected, maybe we'll call it the expected. And I change this up every time I do it, just because I know that when I start saying theoretical, unless you are more science minded than you need to be, you usually aren't thinking in those terms. So let's just call this the expected output. Okay. Meaning that for every 100 that is lost, we're going to replace with 75. Okay. So now you know the variables, or at least are starting to learn the variables. So the formula is you take the actual output, so just call actual output, over the expected output, and then multiply that by the replacement volume. You can even call that N if you want. Okay, sorry for my terrible handwriting. Anyways, so what is my actual output? 800 milliliters. What's my expected output? 100 milliliters. What's my replacement volume? 75 milliliters. And so you would just do 800 times 75 divided by 100, or you can reduce 800 over 108 times 75, and you'll get a replacement number of 600 milliliters. And I just want to double check. Yeah. 600 milliliters. Okay. Now, sometimes your actual output might be less than the expected. You would still follow the same formula because then you would just replace with less volume via the PEG tube. Meaning, let's say it was 100 milliliters expected, but the actual output was only 50 milliliters. You would just replace with half of 75. So that's how you would do this type of fluid replacement question. I'm just scrolling down to see if there's anything else that I think is good to look at. Yeah, and these are just the drop factor questions. Just remember, especially if you're at the other campuses, it might just say, what is the flow rate? Or calculate the flow rate. You need to know, are we doing milliliters per hour or drops per minute? And the reasoning or the explanation would be, if they give you the drop factor, that's your clue that you're doing drops per minute. If you're at Allegheny campus, you're going to know, because it's going to tell you what is the flow rate in drops per minute. They're going to be a little bit more specific about that. But it's good to know both ways, because if you are taking the NCLEX, which you will be taking the NCLEX, you need to know how to interpret these. I'm just looking to see if there's anything else. Yeah, so I don't know that you have too much in the form of weight-based. Let me just see. Oh, here we go. Yes. Okay. So this is a weight-based question, and really, there's two ways that this will be given to you. They'll give you the kilograms, and then you just multiply the weight-based order by the kilograms, or they'll give you it in pounds, and you need to know to convert pounds to kilograms. So let's change this up a little bit. Let's make this 5 milligrams per kilogram, and let's make the patient's weight be 182. Okay. So if you're at North, South, or Boise, you may have been okay. Yeah, I'll come back to number 15. Absolutely. So when we do this particular type of question, couple things you want to do is, so if you're at North, South, or Boise, you have probably been told not to round your pounds to kilograms right off the bat. Wait until you're done with your equation. So let's work that out. If I'm doing this and I want to save my rounding to the end, it's helpful to do the full-on dimensional analysis. And then I'll show you an alternative way in just a second. Okay. So we're going to convert pounds to kilograms. We know that 1 kilogram is 2.2 pounds. At this point, even before we do any kind of math, we're in kilograms. So now I'm just going to multiply by my loading dose, which is that 5 milligrams per kilogram. That eliminates that. And then we just plug that into our calculator. 182 times 5 divided by 2.2 will give us 413.636363. So this patient's going to receive 413.6 milligrams of dilantin. Now, the other thing they might do is they might give you an available for the dilantin. So the dilantin might be available in 250 milligrams per 5 ml. Okay. Then you would just convert it and solve for how many milliliters this would be. Now, if you're not a big fan of doing the long dimensional analysis, you're still doing it. You're still doing this, but sometimes it's helpful just to chop it up. So if you're at Allegheny campus, it's probably fine to do this, and I'll show you what's going to happen here. I'm just going to divide this by 2.2 to get to my kilograms. So 182 divided by 2.2 will give me 82.727272. So I'm just going to say 82.7 kilograms. I'm going to multiply by 5 milligrams per kilogram. So 82.7 times 5. And here I am going to get a slightly different answer. I'm going to get 413.5 milligrams. Okay. So if we're at Allegheny campus, this most likely will be the answer. If for some reason, if you get if you do it the long way and you get this answer and they mark it wrong for some reason, you should, if you're showing your work, you should be able to argue your answer. I will say that this right here is the best answer. Okay, because we saved the rounding to the end. I would also argue that this is an acceptable answer, but you need to kind of run that out with your lab instructor. Okay, because I'm not, if I were the one grading it, then we would have a conversation. But I'm not the one who's grading your test. So, and then the question was, do we just ignore the 300? We're only calculating the loading dose, right? So yeah, the 300 milligrams per day would just be what you would do the next day. So you start off with the loading dose and then 300 milligrams per day. So it's just extra information. So yes, you would just ignore the 300 because it doesn't factor into your equation. Good question. All right. So number 15, let's see. What that is. Yeah, so this might be asked a couple different ways. So if you're labeling this, there's a couple of ways to do this. If you go to, like in the OneDrive folder, it talks about mixing 2 insulins into 1 syringe. So the first thing is, if you see this image, that's the syringe you're going to use. The reason being is because that syringe is in units and your insulin is in units. Okay, so we're not going to use syringe A, we're going to use syringe B. It tells you to do a couple things. I've seen that some of the tests that have been updated and it just asks you to mark the total. For this question, I added some extra information. I wrote in that you would draw up the 10 units of regular insulin first. So I would make sure you write that down just to kind of make sure that they know, your instructor knows that you know what you're drawing up first. When you mark the syringe, when they ask, and according to the textbook, the 2 marks they're looking for are the total. So that one's pretty straightforward, right? So here's our total insulin, both MPH plus regular insulin. What did we draw up first? We drew up the 10 units of regular insulin first. In a hypothetical situation, assuming that the insulins did not mix upon pulling them up, the 10 units, because it was drawn up first, would technically, I'll say not technically, but hypothetically, would be between the first 2 points. So your regular insulin would exist in this domain between 40 and 50. Okay. In reality, that's not the case. Okay. And then your NPH would actually be the rest of this here. This would actually be your NPH. Okay. So if you're asking me, like, what do they want? This is how I think they want you to mark this type of syringe. Again, I've only ever seen this at Allegheny campus. I haven't seen you being asked to mark a syringe like this at North or South or Boyce. Usually it's just mark the syringe and then shade the dose. Let me show you an example of that. And I'll come right back to that. Usually they're going to tell you something like this. It'll tell you to shade the dose. So let's say we get an answer of 1.4 milliliters. I'm going to go to my syringe. Here's my 1.5. So here's my 1.4. I'm going to shade my syringe to the 1.4. Okay. So that's how you would answer that question. And then most likely how you would see that. This question, if they ask you about mixing insulin syringes, and if they ask you how or to mark this, just make sure you're adding in these details, and then ask before you take the test. Maybe even send your lab instructor an email and just say, you know, if we get asked a question about marking or mixing to how do you want us to mark that, and get some clarification on that. All right. Do you have any questions? I don't want to chew up all the time with just me, because I've already done this a couple of times. Any questions you have?
I think it would be helpful if we could go over like just one reconstitution problem.
Sure. All right, so this is an example reconstitution problem. Like I said, there's some other another reconstitution example that is on the 220, 230 Boyce packet. So if you want to see an additional practice, that's there. So what I'm going to do is I'm going to do what I've been doing. I'm actually going to change the order on this, so that way we can kind of do this fresh. And then I'll review this too, since it's been a little while since you may have looked at this. And then if you're at Allegheny campus, you don't really need to worry about this, but you might see this on the NCLEX. So if you can understand what's happening here, I think you'll be ahead of the game. All right. So for this example, our order is 725 milligrams intramuscular every 6 hours. Now, first of all, you need to know, like you can see here, the way it's worded, it says how much medication will the patient receive in one dose. We don't know. We don't know. It doesn't tell us how, how it's going to be delivered. So, but you already know, because the fact that it's IM, intramuscular, that's your indication that we are in milliliters. Okay. So if you ever get stuck on that, that's how you know, is if it's IM, SC, IV, then we know it's in milliliters, because we're not going to try and shove, pills transdermally into the body. Okay. If it's by mouth, it could be ml, it could be tablet, it could be capsule. It just depends on what we have available. Okay. The next thing is, and how we know we're dealing with a reconstitution, is if you know you're looking for milliliters, when you look at your label, you'll see it'll say 1 gram. It doesn't say anything about 1 gram per milliliter or 450 milligrams per milliliter, like you would see in a suspension label. So when you see that, now you know you're dealing with a reconstitution. So when you know you're dealing with a reconstitution, you need to come and look at the label and the instructions. So the instructions tell you what to do reconstitution wise. Now, the reason, like, you might be like, oh, I can see what I need, I'm just going to go through this. Every label is just a little bit different. So it's helpful to I think it's helpful that I go through this just to kind of show you how to find the information that you might be looking for in case it is a different label, and they're going to use a variety of different labels. If you're at Allegheny campus and you see the Pfizer pen label and you see all that milliliters diluent added, this is where that information came from. We just didn't show you the label. Okay. But if you do a Google image search for Pfizer pen, you'll see what that looks like, and also why we simplified it. All right. Anyways. So it tells you for intramuscular use, which is what we're doing, you're going to add 2.5 milliliters sterile water. So it's telling the pharmacy or telling you to add 2.5 milliliters. You're going to shake it up. So you're adding 2.5 milliliters sterile water to the dry powder that's in this bottle. You shake it up, and that's going to give you a total volume of 3 milliliters. Okay. Then the magical thing that we're looking for is it also tells you the concentration. The concentration for this 1 gram Kefzol is 330 milligrams per milliliter. Okay. Now that you know that, now you can go ahead and solve your problem. So my order, 725 milligrams. My available, 330 milligrams per milliliter. And if you're doing this ordered over half, it's 725 divided by 330. So 725 divided by 330. I'm going to get 2.196969 repeating. So I'm just going to round that 2.19 to 2.2 milliliters. So you would put that as your answer, and then you would shade 2.2 milliliters on the syringe. Now, earlier I deleted it. I had like I had another number there for the strength. I have seen some labels where it gives you the total volume, but it doesn't give you the concentration. Okay, so it doesn't give you the 330 milligrams per milliliter. If you were to have a problem like that, you would take the total amount. So 1 gram is 1,000 milligrams, and divide by the volume, the total volume. Okay, now it's an approximate. And when you do that, you actually get 333.33 milligrams per milliliter. Notice that they made it 330 milligrams per milliliter. So even that is technically an estimate. But this is what you would do if for some reason they didn't give you the 330 milligrams per milliliter. This is how you would set that up, or how you would find out what the concentration was. The good news is I've seen that as examples, like if I do a search for a reconstitution, but I have not seen that as an example that you would actually have to do on a test situation. If you're Allegheny campus, this is what your reconstitution questions look a little bit different. I think they're down here. Yeah. It's going to say like to choose the strongest concentration from the list of available concentrations here. So for this one, it's 20 milligrams per milliliter. And then you just solve for how many milliliters, or you'll see the Pfizer pen question. The Pfizer pen question, what you need to know is that you ignore these milliliters diluent added. That's just telling, like I said, you or the pharmacy how much sterile water to add to the powder to get to the units per ml. So what I have circled here, that's your concentration. That's what you care about. That's your suspension. Okay, that's your units or milligrams or micrograms per milliliter, or your milliequivalents per milliliter. It's what tells you what to administer. Yes, yeah, I'm recording this, and I will upload this just like I have all the other ones. Yes. I won't have this up probably until tomorrow. This one, but I do have Tuesday's reviews are already posted on YouTube. All right. Any other questions? Like,
I'm not.
so
I'm not
Okay.
used to starting out with like micrograms. If it says like if the way we do it is if it always the last question, how many mLs or how many mics or milligrams, I always start out with that unit.
Okay. No, that's fine. I used to call that start with the end in mind, is kind of like how I would like put my mindset into doing that. And I can show you how to do that. I usually just start with the order, and it's just preference, right? So what you just told me and what I'm showing you both are applicable. So let me show you what I think what you're doing, and then so we can be on the same page. So
Thank
you did this 0.05 milligrams. Then you put your micrograms next, or did you convert this to micrograms next?
Yeah, the problem was I put 50 mics on top, but those don't cross out.
Correct. Yeah, so you need to convert. So like step one would be, at least in my mind, is I would want to convert the milligrams to micrograms, right? Then you can put your 500 micrograms. Then
Gotcha.
you can, yeah.
Thanks.
And then that should give you your answer.
All right, thank you.
You're welcome. And then, like I said, the alternative way is if you just make your if you just convert it right off the bat. So if you just convert the 500 micrograms to 0.5 milligrams from the get-go, or your 0.05 milligrams to 50 micrograms, then now you're in the same unit, and then now you can do the math. So some of you are learning, like, you can do this multiple different ways, right? And hopefully you're also learning that you're working with somebody that I'm not going to tell you to only do it my way. I might just ask you to explain what you're doing so I can figure out how you're trying to figure it out. And then I think I can help you get across the bridge there. So, all right. Well, that's our time for today. Like I said, I will upload this onto YouTube. If I don't have much attendance for the 220, 230, or the 240, I'll try and upload that during their times. But if I